we should collaborate with neighbors. We're working on the same crops. What do you got? He's like, have you heard of harvest weed seed control? And I had not. We've been looking at it kind of ever since because it's a fun subject, and we'll kind of dig into that here. I'm the first of 3 harvest weed seed control talks at the symposium, so I'm going to focus on the east, the Prashant, the central U.S., and then Lovreet, Shergill, and in the western U.S., and we'll kind of have our harvest weed seed control manifest destiny here. But since I'm first, I'm going to talk about what is harvest weed seed control, and I'll get into kind of where we are in the eastern U.S., what we just kind of wrapped up, where we're going, what are some of the challenges that we've seen along the way, and I don't think we can really overlook those, and then where we're going in the future. All right, so what is harvest weed seed control? I'm sure many of you have heard of it and thought about it and understand it, but it really takes advantage of the situation you see here is that the weed seeds retained on the plant at the time of harvest above that combine cutter bar are going to end up into the combine, right? And so farmers like this is Ray Harrington, really one of the farmer champions in Western Australia, that realized that these herbicide-resistant weeds are going to beat us and they're going to put us out of business if we don't do something different. And so harvest weed seed control is really a direct response to herbicide resistance and the epidemic that they're having in Australia. And so the idea is that we're spreading these weed seeds out to beat us into a herbicide program and a crop competition, and that's not a good thing. There's an opportunity for management here, and let's take advantage of that. So that's really what we're doing with harvest weed seed control. It's important to acknowledge this is kind of novel in the U.S., right? This is a novel weed tactic symposium, but this is not a novel technology in Australia. They've been doing this really for decades there. It's probably about 80% or more adopted in some form or fashion in the Western Australia region. And so to me that speaks that it's adoptable, right? It can work at commercial scale, it's economical, and it's working for weed control. I don't think we'd see levels of adoption that high if it wasn't. All right, so how does it work? There's various ways to do it. Once we have those seeds in the combine, there's various things we can do with them. We can destroy them, so the seed impact mills are kind of the most technologically advanced way to do that. But we could also just drop all the residues, the straw, the chaff, and the weed seeds into a narrow window and burn it, right? And that's probably the least technologically advanced way of doing it. And that's kind of where it started in Australia, but certainly there's some challenges with burning residues. We can also concentrate the residues, so chaff lining is a form of this, so you take just the chaff fraction, which is where the weed seeds exit the combine for the most part, and just drop those in a line. We're not killing the weed seeds, but we are concentrating them, right? And chaff train lining is kind of a method that's suitable for controlled traffic farming that would just deposit that into 2 lanes on the wheel tracks instead of 1 in the center. And we can also remove the weed seeds through like a mail direct system and some others. But really, I think for the U.S., it's going to be concentrating in chaff lining, and then the seed impact mills are going to be where we're looking. All right, so the previous research that we've done is, first of all, we have to have those weed seeds retained on the plant at harvest time. If we don't, there's not really an opportunity for harvest weed seed control. So this is some of the work that the GROW team did, led by Lauren Lazaro, actually 3 papers on this. This is the broadleaf, but there's also grass seed retention and factors that influence paper on factors that influence seed retention here. But this is at soybean maturity, so various broadleaf species here. So the first opportunity for soybean harvest, 2, 3, and then 4 weeks later. And then the dark blue represent more of the site years across this study, which is really a lot of states involved in here. And then this is just percent shatter, right? So we want low shatter, that's good for harvest weed control to retain on the plant. And you can see we really have a good opportunity for some of our most problematic weeds there, in particular our amaranthus species for the U.S. there. All right, and then you think about what kind of crops these are infesting and what crops are harvested with a platform header, right? So the crops in Australia all have that grain or platform header. And so soybeans is kind of the first one that comes to mind. A lot of herbicide resistance issues there, but rice and wheat, we could probably add sorghum to this list, but certainly millions of acres of cropland that we could use this in. We ought to think that we'll talk more about crops that are harvested differently. So corn and cotton would be 2 big ones there that maybe are not currently amenable to harvest and seed control, but we'll look into that there. So I'm going to focus on the eastern U.S. To my knowledge, there's active programs going on in Texas, Louisiana, North Carolina, Virginia, Delaware, and Maryland. So that's kind of where some of this comes from. All right, so what have we kind of recently wrapped up? One of the things is chaff lining. So this is a picture of our small plot research here. You can see the weeds coming up there in the spring prior to planting. And when we started this research, we were like, well, how much chaff do we put down in the row? And we didn't really know, right? So that's kind of spurred on one of our first projects, was trying to figure out how much chaff is out there. The Australians have done a good job characterizing this in wheat. We know that as the wheat yield increases, we're going to have more chaff. And certainly as our combine hair width gets wider, we're going to get more chaff. But we don't know that for soybeans. That's something that we sought out to do. And I think this would be helpful to go through just for harvest weed seed control, but also to kind of explain how we did this. And so here's my cartoon of a combine, right? So the crop comes in, the cutter bar goes up and into, this is the rotor in the modern combines, and there's really sort of two sections of that, but it's all kind of one big thing. Thresher and the separator, right? And the big residues, the straw fractions, are going to kind of go over the top into the beater, and then out the straw chopper and get spread out across the field, right? The small residues, the chaff fraction, and the weed seeds, if we have this tuned right, and the grain are all going to land on the sieves. There's the fan, the cleaning one that's going to blow that out. But these residues in conventional harvest come back together and we spread those out. When we look at harvest weed seed control, we add a baffle right here, right? And that keeps these two streams, the chaff, which has the weed seeds in it, and the straw separated, and then we can basically do something with that at that point, right? Whether that's a seed impact hill, whether that's a chaff lining chute, et cetera. But this is what we need to kind of measure to see what will get into that chaff line. All right, so we kind of do the harvest index of soybean, right? For most crops, it's about 50%. So that's what we saw here, but this is the separation we didn't know between chaff and straw. And so basically we figured that out, and it's about 13.4% by weight, right? So if we got 100 pounds per acre of soybean yield, we have about 13.4 pounds of chaff going into that line. We can also take these values, though, and look at the nutrient contents of those. So we sent these off and got them analyzed for N, P, K, and S, and there is some, maybe between 0.5% and 2% for those various nutrients in there. But it's important when we think about, these various fractions might be condensed, they might be removed from the field with various harvest weed seed control, and so we might have to account for those with nutrients. And so the cost to replace these nutrients could be a significant factor that we need to, when we're talking about adoption of harvest weed seed control, we need to know how much these things cost, right? So there's various systems here, various outcomes for the chaff and the straw. But when you look at this across using a 5-year average fertilizer price and a 50 bushel per acre soybean, which is about our national soybean average yield, you come up with this in terms of the dollar per hectare there. So there's somewhat of a cost associated with that. Okay, and that's if you are going to account for those and spread out fertilizer basically to replace that. All right, so now we know how much chaff is in there. It allowed us to do some of these small plot experiments. We just collected some weed-free chaff. We laid it down in some lines at varying rates, right, to account for varying wheat yields or soybean yields. Added some weed seeds to that, compared that to spraying the weed seeds out in a conventional manner. And I talked about this yesterday for wheat, and we're going to be publishing this here shortly, or submitting it at least. But basically what we found is that the chaff is going to inhibit some subsequent crop emergence. So here was wheat chaff. We double crop all of our soybeans, or all of our wheat acres with soybean. So you can see it really limited the amount of soybean coming up there in these plots. But at the field scale, when you count for the chaff line, it's only part of what you have out there. That's, you got 30 competitors on chaff line every 30 feet, right? So you have to count for all that area outside the chaff line. We did not see a reduction in our soybean yield there. In the wheat, we only saw like 1 out of 7 site years of reduction in wheat yield over the chaff line there. So soybean chaff has a lot higher nitrogen, it decomposes quicker, and we didn't see as big effects there with soybean residue there. So the crop concerns, I think, are kind of minimal here. You are going to have some reduced emergence there, so that's something to at least be aware of. But that was, kind of good for the goose is good for the gander, right? If we have a reduced in crop emergence, we also had a reduction in the weed emergence in that line. We were seeing some fairly substantial reductions across our wheat and soybean chaff line of about 30 to 50% reduced emergence at the field scale relative to when we spread out all the weed seed with conventional harvest. So greater amounts of chaff did lead to more suppression, right? But you don't exactly control that. You get the yield that you get. We all want big yield, but sometimes we don't get that. And the chaff lines reduced this, but didn't eliminate weed emergence in those chaff lines. So we still had to manage the weed seeds in those chaff lines. Okay, let's kind of transition to some ongoing work, and so a lot of this involves the ground crop seed control unit. At this time, sort of what we use in Virginia, but here you can see this is where it adds on to the back, in this case, a John Deere 680 combine. And you can see the exits of the twin mills down here, and then here's that straw chopper up there. And so one of the first questions we have is if we're getting weed seeds in front of the combine, are they making it to that mill, right? And then subject to if that mill kills the seeds, or are they escaping it in that straw fraction, right? We talked about that. So this is some of the work we did. My PhD student Eli Russell presented this in the single slide talk, excuse me. Actually Tuesday, and then again on Wednesday because they made the final round and ended up getting second place. So good job, Eli there. But this was basically, we had a hose and we would funnel weed seeds down into the front. We caught the stuff that was coming out of the back as we captured that as it came out. And for red root pigweed, that was the seed where we found the most coming out in straw fraction. It was still only about 5% weed seeds escaping there. So the vast majority was not coming out in the straw fraction, which would mean it was either subjected to the seed impact mill or it ended up in a grain tank. For the purposes of weed management, it's being removed. So those seeds in general, according to how they had the combine set up, there's a lot of variables here, but crop competition, crop harvest conditions and how you set up the combine. But in general, just kind of as the farmer had it set up, we work with most of the seeds where we want to, which is the harvest weed seed control device. We also looked at the seed kill, and so here we had a grad student right over in the back. Four weed seeds down a funnel, and the end of that hose basically ended right above the seed impact mill there. And so we just caught all these mesh bags, this is sort of the Michael Walsh protocol that we followed. All right, so then we could take those residues, mix them with some potty mix and grow them out. And so this would have been a non-treated, so a non-processed seed, but still with that same growing media there. And what we've seen is really high kill rates. It says wild mustard, this is really canola, the proxy for wild mustard. Over 98% kill of those two. Ryegrass is the one we've seen less kill of. This particular study ended about 89%. But we've seen some of our other studies be as high as 94%. But that seems to be a tougher weed. Talk about why that is, but a tougher one to kill with the seed impact mill there. In soybeans, we've seen excellent control of common rag and palm grain. We've got ongoing studies with other weeds, and we're also going to be looking at other seed impact mills. So I do want to thank Redicop for partnering with us and help supply some of these units, as well as IHSC. They supplied us with this test stand here, maybe not the best pictures, but there's just basically we drop the residue in here, and it's kind of just half of their twin mill. So it goes into there, and then through the mill, and we'll be able to test a lot of different things here, as we will with the Redicop stationary test stand. So the amount of chaff, various weed species, so on and so forth. Chaff moisture, I think, is going to be a big one, and we'll talk about that here later on. That's going to be one that we'll really use these mills for quite a bit. All right, so if we get the weed seed in the front, it goes where we want it to. We get it, killed in the mill pretty well. Does that result in changes at the field level, right? So we ran these just simple fields with it and without some infested areas. Eli also presented some of this in the talk on Tuesday, and I'll just kind of briefly go over a couple of the data points here. So this is common ragweed density in June, so kind of before that post-emergence application would be applied, following just one harvest, that fall prior to the about seed control unit. Had 5 fields here. Some we saw reductions, some we didn't. On average, about a 23% reduction at that time. Post-emergence herbicide was applied, and we came back again later, so it's sort of a second emergence cohort, if you will. At harvest, we observed about a 50% reduction at harvest there. So we're going to try to keep these things going through time. But one thing we have to look at is these long-term rotations, right? Corn is a crop that has a very different harvest mechanism at the front of the combine, and so we may not see as many weed seeds into it. But we have started with the grow team, a lot of different sites that are going to be going through this corn soybean rotation and looking at this. And so we're just kind of getting started with that. Another thing farmers are wanting to see is, what is the operating cost of this, right? It is going to take more horsepower, which is going to burn more fuel. Is that going to, first of all, how much more is that going to cost me? But then is that going to slow me down at harvest? And so, we've seen here in the week, we are going to use more energy capacity and more fuel. That's not a big surprise. But at least on this Class 8 combine, we did not reduce our travel speed here. We've seen some similar numbers in soybeans as far as not reducing travel speed. I will say, my understanding from Australia is they've got about a 10% reduction in harvest capacity for these mills. And so we're still learning about this, and this is just some preliminary data at this point. One thing about the corn header is that there's these gathering chains, and then there's these plates that kind of break off the corn cob, and underneath that are these rollers that suck the stalk down. Right? So there's a big gap here for all the weed seeds to get sucked down with all that material. And so there was a poster on this, Kevin Bradley's group and his co-authors, which I'm not a part of, but I believe they have about a 70% loss of the seeds here at the header, right? So we're not getting very many seeds at the combine. We're not suggesting harvest weeds control. We just did some more preliminary stuff looking at this device, the 360 Yield Saver. These are just some brushes off the shelf designed to help get more corn grains in. And maybe that'll help us get some weed seed in there too. All right, this is some work from Texas A&M, and this is all them, so I don't want to take any credit for it, but this is the weed seed retention out there on the plants after the cotton harvester, whether that's a picker or stripper, have gone through, right? So you could potentially come back across that field and gather those weed seeds and do something with them. So maybe with a picker situation there, 65% of the seeds, that might be worthwhile. All right, I do want to get to some of the challenges here before Lynn comes and gets me. Moisture is a big deal with these injectables, and I think my understanding is once we get about 18% or higher chaff moisture, any of these units that are commercially on the market are going to start to have trouble, right? This particular instance wasn't the mill plugging itself, but it was actually bridging before the material got to the mill. But in either case, right, the farmer's not happy, and that's going to be an issue that we have to overcome. I know that these companies are aware of this; they're working on that. But the harvest conditions in Australia are not like what we have in the U.S., and so we're going to have to adapt the technology, I think, to get to that. You know, this was in rice. Maybe some of this is combine settings where we're not getting the large residues kept up in that feeder. They're kind of being overthreshed maybe and getting down into the sieves. So there's probably a learning curve that we'll have to go through here, but there are some challenges we'll have to overcome there. We do have some future work. You know, we want to look at a cost calculator. As we continue to see, and our research really shows massive potential for harvest weed seed control. You know, if that continues to be the case, we want to try to drive commercial adoption.
By acknowledging all the co-authors and the collaborators from multiple states across the Midwest and the southern US, all the graduate students and the postdocs involved from Iowa State as well as in other universities. So as we know that multiple herbicide resistant palmer amaranth and 9-way resistant palmer amaranth reported in Arkansas recently, and 7-way stacked resistance that we see in the Midwest and water populations has driven the need for more integrated weed management strategies in the region. So at Iowa State, we have a lot of collaborative work over multiple states looking at a systems level how we can incorporate these IWN programs in our soybean-based cropping systems, predominantly in consort interventions. With the ultimate goal right now is to plant into a very low weed seed bank. So at this point in time, when I talk to the growers in my extension talk in Iowa, I focus on how we are going to manage the weed seed bank. Okay, so for today's presentation, I'm going to focus and show some of the results just on the harvest weed seed control. We have a lot of data on other aspects of the IWM concept. So I think Michael has mentioned that in his talk about the seed retention of different weed species. And this is the data from Iowa over the last 2 years, 2020 and 2022. At the typical harvest dates, this is the 2020 year, in 21-22. At the minimum, you can still have 70% of those water seeds that are still retaining the seeds at the time of harvest over the last 3 years. Dr. Roseman has done that work also previously, that has been published also. Claudio was part of that. But this is more recent. We found that more than 90% of the palmer amaranth seeds can still retain at the time of harvest. So there's a great potential for capturing those seeds and managing those or destroying them. So one of the strategies to manage those, as Michael mentioned, is chaff line, very widely adopted by Australian growers as a very inexpensive method, and we were the first one in the US to bring that chaff lining equipment from Australia, West Broiler Ag company based in Australia. Less than $7,000 including the shipping cost. And we have like 5 of these units running on multiple fields in Iowa as well as also in other states now. Pretty easy to install, no major modifications to the combine. We ran several thousand acres on the soybean fields over the last couple of years with this. So all your straw is being separated by the baffle, and all the chaff is coming at the bottom through this chute that is attached at the rear of the combine. So this was the production field from in central Iowa when we started this, where the grower was really struggling with managing multiple herbicide-resistant water. And this is a grower production field in central Iowa that survived 3 passes of herbicide applications during the season. And this is the same field, as you can see, we laid the chaff lines with our chaff liner attached to the John Deere S660 combine, and you can see the chaff lines right to the center of those 35-foot header width that was the header width for the combine. And the whole objective of this chaff lining is to concentrate your weed seeds right here in the chaff lines and minimizing the spread across that 35-foot header width as the combine passes through the soybean field. And these are my grad students and work at collecting samples, both when inside the chaff line as well as outside the chaff line as the combine was passing through that field. When we laid out with that commercial chaff liner kit, the soybean chaff lines were 18 to 22 inches wide, and they were 6 to 8 inches deep. But over the over the growing season or coming to the next season, there was definitely more settling down of that chaff line. However, one of the major objectives of this chaff lining is to reduce the spread of herbicide-resistant weeds across the field on a per-acre basis. And we put some trays inside and outside. And these are all the water hemp seeds, millions of water hemp seeds that we collected. And more than 95% of the water hemp seeds were concentrated right here in the chaff line compared to outside the chaff line area of the plot. So that, if you will do the math right, now you spreading all the seeds or reducing the spread of the seeds by, just only by more than 95%. We also wanted to look at the efficacy of chaff lining on water hemp, and again, this work was funded by United Soybean Board. Carla Gage had some of this data from multiple states looking at the viability. As you can see, we were putting seed packets both inside and outside the chaff line area of the plots, and definitely also looking at how this approach is going to influence the weed emergence patterns in the presence or absence of herbicides in the following growing seasons. We got funding from the USD and WSSA CPPM with partnerships from Southern Illinois University of Arkansas and Cornell University now, looking at some of these ecological factors, for example, seed predation. So this is some of the data from Iowa back from 2015 by Matt Liebman, who retired now from Iowa State, looking at some of these insect predators. And we believe that this amount of chaff and containing millions of weed seeds is definitely going to be a good source for the predators. Okay, so based on this data, water hemp and small-seeded lamb's quarter, these species were preferred by the field crickets, and this is the data of percent consumed on a 24-hour time frame. So there is definitely really potential to capture that. This is what exactly happens in the following growing season. All those fields, we planted back some of those fields to soybean, we planted back some of the fields to corn. And just to see as a demonstration, in the absence of crop you are seeing here, this is the 35-foot header width of the plot, and this is the chaff line right here, the emergence versus outside. And these are again the chaff line right here when we planted it back to soybeans. Pretty stable. There was still there was not a whole lot of movement because of the wind or rain or precipitation. They were pretty stable right there in between the 13 soybean rows, and a lot of water and emergence in the following growing season. We planted some of those studies from like the chaff line fields from soybean to corn, and you can see the right here. This is the chaff line and the corn rows in between, and the chaff line in between the corn rows. It stayed pretty consistent, and we saw some reduction in the growth, some fluorescence happening here because of the nutrient binding of that chaff, but overall there was no reduction in the yield at the end of the growing season over multiple locations from the chaff line. We were monitoring the temperature and moisture within the chaff line and outside the chaff line just to understand the microclimate difference as a result of the soybean chaff that is going to impact our emergence patterns as well as seed and dynamics of water hand. We came back to the same fields and we had 3 herbicide programs, the standard in corn phase of the rotation. One is the standard pre-application of herbicide, and the standard pre followed by banded post, where what we mean by banded post is we only sprayed the chaff line as a banded application, and then we had a standard 2-pass pre followed by broadcast post. This is some of the data here. I want to focus your attention on the left hand side here. This is in the absence of any herbicides, looking at the chaff line by herbicide interactions. This is the proportion of immersed water and seedlings at different days after soil planting. The red line indicates the water hemp emergence inside the chaff line, and the green line indicates outside the chaff line. So pretty clear that there was a separation of water hemp emergence, and there was delayed emergence of water hemp inside the chaff line of the plot versus outside. We also saw a very important mechanism here, synergistic activity with the pre-emergence herbicide. With the application of pre-emergence herbicide inside the chaff line, there was further delay in the emergence as compared to outside the chaff line. So there is definitely a complementary strategy. Looking at the data, on the right hand side, you see that these are the set of herbicide treatments, same set of herbicide treatments inside versus outside, water and density 6 weeks after the pre-treatment of Acuron and 6 weeks after the post of end season. As you imagine, the majority of your water seeds are concentrated on the chaff line. That's where we got a lot of emergence and very less emergence, a drastic reduction outside the chaff line, okay? Because there was very strong reduction in the number of seeds that were outside. So when we talk about chaff line, we got to be very careful in managing this chaff line, right? So a single pre-application, 30 days, 30 water seedlings, 6 weeks after pre, water and common element keeps on emerging. So you need to have a pre followed by post to reduce that number. However, outside the chaff line area of the plot, we were able to get only 2 water and seedlings, and there was no need for additional advantage from a second follow-up post application. What does that tell you? Is that we're reducing the number of herbicide passes and the volume of herbicide. Also, what I would like to emphasize, and I forgot to mention here, that this is the post-banded and this is the post-broadcasting, and there were no significant differences in the weed control. One of the important mechanisms we also saw in our plots over the 2 growing seasons, at the time of our post-herbicide application, this is what's inside the chaff line, this is outside the chaff line, same plot. Okay? What we saw there was, because of the delayed emergence, all the water hemp took more time to emerge. So there was delayed emergence, smaller size of the water hemp plants at the time of delivery application, which means you are enhancing the efficacy of your herbicide as compared to what we saw outside. So that's again a complementary strategy, and definitely overall, I don't want to show all the data here, but we saw a definitely synergistic interaction between chaff lining and our herbicide programs, a drastic potential for reduction in the spread of herbicide-resistant weeds on a per acre basis. And over the growing seasons, again, you can focus on some of the banded applications and other strategies which will result in the reduction in the herbicide use on a per volume basis, on a per acre basis, as well as selection pressure. Going forward, we are looking at banded applications. We've got a shielded sprayer coming in where we are going to target just those chaff lines in the following crop, which is going to be corn, it could be soybean rotation. We are also looking at targeted tillage, and there are some grower fields that we are cooperating with some organic producers in Iowa and Illinois, nearby states, where they're interested in burning, because some of those organic burning is kind of like a sketchy topic, but again, those organic producers have been soybeans, they have been using burning, and they can just do the burning of those chaff lines in the fall, not the entire field. So we have some long-term studies going on. This is some of the data from Dr. Noseworthy's group at the University of Arkansas when he really started working on this harvest weed control back in 2013-14 timeframe for the first time in the US. there is definitely burning, some wind is needed, and over 400 degrees Celsius in the soybean chaff, you can see a complete control of palm emerald, body grass, Johnson grass, and pitted morning glory. And that's amazing. I mean, if that road is, I was a little afraid of that, about the burning side, but he said that he can selectively burn those chaff lines in the fall and come back again in the spring. So this is palm emerald and burnt, as you can see here, and barnyard grass. Okay. All right. A few slides on the high impact mineral of the seed structure. I'm not going to talk about the technology here. We do have 2 of these units. We started in 2020, attached to John Deere S680 combine, draws 35 to 40 additional horsepower. I would say with confidence there's a lot of potential for this in the state of Iowa, and there are like 3 or 4 growers right now who are about to purchase these units based on our research on those and demonstrations on those grower fields. We have we have successfully adopted and run this equipment ready crop seed destructor over close to 5,000 acres of soybean over the growing season. Some of the results here, this is data in Iowa fall 2022, and again, similar results were obtained in Arkansas. Kevin Bradley, he has a seed terminator, and then I got this ready crop unit. On an average, 20 to 30%, and this is the data for the last 3 years. From header loss, as the header is hitting is watering plants because of the shatter. So again, that's what I tell the growers. There is an investment of $75,000 in this equipment right now to buy as an add-on feature with the John Deere combines. But again, don't assume that you're going to see the results in the first year, because when we talk about palm and emerald or water, it's a numbers game. 20 to 30% of 1 million seeds per plant is still a huge amount. And that's why you saw that in Michael's data, even in the first year, the reduction was only 20% in the emergence. And this is the grain tank loss that we are quantifying, and the threshold loss, and what's coming at the year from the seed destructor unit. We're collecting those in the trays. We put those under the microscope. This is the level of physical damage or destruction that you're going to see with the seed destructor, the ready crop. And this is palm emerald data. We do have water hemp. More than 90% of the water hemp and palm emerald, and this is data from Iowa and Kansas, as well as from Dr. Noseworthy's this year, last year's trial. They will fall in this moderately cracked to severely pulverized or fully broken seeds. And we put those in the germination trays, none of those germinated. We did the viability test, none of those seeds were viable. So our growers were also interested in looking like, can we use this also in corn? If we have this unit, why not we cannot use it in corn? So Dr. Bradley got a grant from National Corn Growers, and myself, Dr. Noseworthy, Bradley, and several of the folks we looked at this, but this is the data. We ran this for the first time last fall, and this is some of the data that Dr. Bradley's student Hill has shown already in a poster number 60. This is the big wheat seeds. So we see a 93% capturing and reduction of the seed bed input at the time of harvest in corn. So it is very effective also in corn based on the rotation. So you would expect a faster decline if the grower is going to use it both in the corn and soybean phases of the rotation. There are long-term studies going on looking at more of the real emergence and the seed bank reductions, and what is the potential for other broadleaf and grassy weeds, and how we can minimize this 25 to 30% seed losses at the time of harvest through header loss, threshold loss, or grain tank loss, and what's the impact when we measure when we go to Arkansas. In our northern climates, it's dry, and we have a short growing season, so we don't have any issues with combine plugging over the last 3 years in Iowa. The only bad experience was picking up a rock, and then it broke the unit, but it was replaced by ready crop. So we have again funding from UST, NEPA. All these teams are involved in this, where we are looking more at a systems level, looking at the impact of cover crop, cereal rye as an early season tactic versus, and then herbicide programs followed by harvest weed seed control and how we can integrate and look everything at a systems level to look at the managing the weeds, pig weed, palm remnant, and waterland in Arkansas, Illinois, as well as Iowa, and now since Vipan Kumar moved to Cornell. They'll also have an economist to do this, looking at the economic benefits and risk of adopting these multi-tactic strategies in our council implementations. I'd like to acknowledge all my funding sources and all my collaborators and the Bill team. And if I have time for questions.
I have a question. So, you're saying that the germination was delayed. I suppose there would be an effect on maturity and seed mutation. So if you use the same process over and over, do you see a beneficial effect over using years? Or you're kind of losing effect in the second?
That's a good question. I think we're going to see some, like a combined.
So every year
additive effect over additives. Yes. And the reduction in emergence was mostly because the soil temperature and moisture was lower.
Okay, I just want to get to our last speaker because we're going to have 15.
Well, I'm glad to see all of you. I was thinking that I'm the last speaker. I may be talking to chairs, but it's really good to see you all. I appreciate your time being here. So I'm going to talk about some of the research which has been conducted in the past and which is ongoing in this region, West, Northwest, and Great Plains. Colorado technically kind of falls in like central Great Plains, but we have some collaborative projects and we do share some research which is coming from there as well. So mostly it's a wheat growing region. A lot of wheat is grown over there. Cereal-based systems, wheat fallow, some barley, and then corn is like a minor crop, not like in the Midwest. And so our focus is mostly cereal-based cropping systems in this region. First, let's go to the Northwest and see what's happening over there. So these were like initial studies which kind of started in 2013, 2014 at Washington State University. With Dr. Rubione leading this project looking at windrow burning, and they showed like some effect of windrow burning to reduce Italian ryegrass emergence. And that's like the first initial study which started, and it was helpful. And he told me that he has seen some of the growers using this tactic in the fields over there. And this is predominantly where they have more rainfall, where they have more residue which they need to manage, and that's the area they were looking at windrow burning, because in this whole region, conservation of residue is very important due to wind erosion and all the other factors. So they also looked at some chaff carts and bale rack systems in those years, and all of these tactics were helpful to reduce weed infestations depending upon when they harvest in the field. Sometimes if they went like 12 days later, they would drop like 20%, in those percentages. So this was a recently published study. You can see that there is a lot of variability. So that's variability across the sites. That's variability across the years. So depending upon the year, depending upon the species, depending upon which field you are, you will have very different results of seed retention and very different efficacy of using these tactics over there. So on average, they're looking at like 50% on average. Most of these species were retaining seed. So due to all this research which has been happening, and there's a lot of adoption of these systems in this area. As per Rubione, he told me that there are almost like 30 mills which are being used by growers in this region, and I think they're talking about like 20 to 25 something which were just sold last year. So there's a lot of interest in the growers that they're going to use these systems, these mills in the system. And then he has also, he was saying he's seen like 5-6 bale rack systems as well in this region. And so there's a lot of growers' interest in using these systems to manage the weeds in those fields. Although the retention is like 50% on average. So, but that's providing some merit to them. So let's change some region. let's move down towards Colorado. So there was this initial study looking at seed retention, which was conducted and published like 2019. They were looking at some problematic weeds. Similar results, downy brome. These are the problematic weeds, and you can see that the retention is very variable. It's just all over the place, and depends upon the species you have, depends upon year, field, and everything. They also did some impact mill testing, stationary impact mill testing on these species, and you can see that it's highly efficacious. So whatever goes in there will be killed. It's a matter of how much goes in there. So that's the problem. So similar to other testing in other places which has been done, that it's really good. So there was no research currently which was in this region. So when I went there in 2020, so kind of started some projects over there to look at what's happening. So this is the preliminary data, first year data, second year was hailed out. So that also adds to the seed bank. Think about that. So you can see that downy brome, close to the physiological maturity, we had very few plants because there were other damages as well. But it's around like 75 to 80%. And then in most of all those species, like this is violets, there is a lot of variation in the seed retention, and as soon as we are getting away from the harvest, or like as the weeds go, the seeds just tend to fall very rapidly. So these are like our initial findings from the research at Montana State University. Since corn and soybean are minor crops, we also wanted to look at if we can target some of those weeds, especially kochia. It is still green at the time of wheat harvest, so it's just going through the harvest like that. So we thought that maybe that there's a potential to target that in corn or soybean, all their minor crops out there. So we looked at a couple of the species which could be problematic. Red root wheat, common or red kochia. So you can see that in corn, Chilpodium album, common lance quarter, it starts around like 28 days before the physiological maturity. And then the red root wheat, it almost retains a lot of seed way before the harvest. And as the corn matures, it starts shedding its seed. And similar with the kochia as well. But when you move to the soybean system, the shedding starts a little bit earlier as well. So there was like a 1 week difference what we found in our this preliminary research we did. And it starts shedding 1 week earlier as compared to the corn. So there is a lot of potential in using these systems in corn and soybean in this area. But even if you go like late, a couple of weeks later, you can still get a lot of seed on the plants, and maybe it'll be helpful to control the HWSC control. So this was another trial, chaff lining, similar to chaff lining we had, which we conducted across this region. And this was part of the CPPM project, and I tagged along that, and which was led by CSU, Colorado State University. And then we had sites in Kansas, Vipan, he's over there, but that's what he was doing over there. And then we had Misha at Oklahoma. So we had all these sites across this region. We were looking at chaff lines in different crops, wheat, sorghum, and corn. So I want to share the results from Montana and Colorado. So our hypothesis was that the chaff lines will reduce wheat emergence in the field compared to non-chaff treatment. So the pictures from Colorado. So corn and sorghum, all the chaff lines were blown away. So we've done that. The reason, so there is a place of innovation. Probably need to chop the chaff into smaller fragments because the chaff was probably too thick. So maybe there is some engineering component over there which can be thicker even top. So they were all blown away, so we were done with the trial. All right. So okay, we have winter wheat. So we had sites of winter wheat in Montana and Colorado. And what we did was we had 2 different chaff levels based on the yield, like 50 and 30 bushels per acre. Should I convert to kgs or it will be fine? So we had these shaft lines where we placed, seeds in layers. Basically, how we tried to mimic how it will fall from the combine, and we placed them in layers in the shaft, and then we had like 20 seeds per treatment for that, and then we evaluated emergence over the whole season, in the fall, spring, summer, and again in the fall. And then we also had some other treatments which didn't have any significant effect, and I don't have the data over here. So this is data from Huntley. We can see that this is a summer count. We didn't get any emergence in the fall. It was a very dry year, so we didn't get any emergence in the fall. But in summer, wherever we had some chaff in there, you can see that it's reducing the emergence of the downy worm. And that similar thing happened in fall as well. Wherever we had no chaff, we had way more weeds in there. So that's interesting findings. Similar results we found in Colorado as well. Wherever we have chaff, every timing, there is a reduction in emergence of downy worm. And that's a really good result to show growers that, okay, there is some merit in doing some of the chaff lining in this region. We also wanted to look at that, does this chaff environment change the germinability of the seeds? So to look at, we took emergence as a parameter to assess germinability. So what we did, we had some seed packets with the 500 seeds or 200 seeds, 500 seeds. 500 seeds in there, and we placed them in the chaff lines, and then we recovered them at the end of the experiment. So whatever which was remaining in those packets, we just put them in these plug flats, and then we just looked at emergence. So that's what we did. So some observations which we made, like the high chaff seed packets, the seeds were more deteriorated in these, and we looked at those. And then we also did that emergence thing. So this is something low chaff. You can see that there's a lot of emergence, and there's relatively less emergence. I'll talk about that. You have some more chaff. Yep, there is emergence. I'm not sure if that's different. I have statistical analysis, so I'll show you that. But when you go to high chaff, like the highest level we had, we saw some, we were excited to see like there is a lot of difference. But I think my excitement was contained when I analyzed the data. So this is like the first year data. I also have data from the second year. So when we analyze data, there's basically no difference. It's just telling us that there is so much variability in that, and it could be possible that some of those packets, because they were left in the field for the whole season, may not have that much of, maybe the chaff was disturbed or something like that. That could have, changed those things. But like you see, like this replicate is, and here we have way more emergence, and over here we have nothing almost. So there could be that variation which we still need to look at. So my last slide. I have some time. Yeah. So with the Grow Network, we are conducting some research in the region as well. So we're looking at some chaff lining trials, in an integrated approach, and in some sites we are having impact mills where we're going to test them, collaborating with the grower in Montana. I'm working with the organic grower in the system, and we'll see that if impact will help in weed management for them. So I think that's it. Thank you so much. Thanks for listening. Any questions?
Thanks, Sarah, for the introduction. To start with, I will talk about some of the work I have started at Kansas State in terms of integrated weed management strategies in the semi-arid Central Great Plains. Before I start, I would like to acknowledge my co-authors on this paper. So I have like a minute or 2 minutes, okay. So I'm just gonna roll over some of the mechanical practices we have been looking at. I will just focus on the harvest weed seed control. This is a kind of the novel approach has been adopted in the US. Very early stage of research we have been doing. And the success of this method of weed control mainly depends on the ability of annual weed species, how much seed they retain at the time of crop harvest. And two methods, as you are familiar, is chaff lining and weed seed destructor, are commonly used under this harvest weed seed control. So in terms of weed species we target under this weed control practice is a palmer amaranth, and we have observed seed shedding potential is between 5 to 10% of palmer amaranth growing in the central Great Plains at the time of soybean harvest. So this is the ready crop seed destructor. We have two impact mills. Some of you are familiar with this unit, and this is a new unit we bought and get onto our S-Series John Deere combine. And we checked or tested this unit in one of the grower field heavily infested with palmer amaranth in grain sorghum at the time of crop harvest. In terms of results, we had a different type of destruction we observed in the samples we took. But in total, we found more than 95% of total seeds we collected from those samples were destructed using the seed destructor. And different percent of the seed destruction we found slightly cracked seed destruction, or moderately cracked, or fully pulverized. And another thing we observed, those two categories, moderately or fully pulverized seeds, were not able to germinate in our germination test. So almost 67% of those seeds came out of that unit were not able to germinate in our germination test. Along with the sorghum, we also tested this unit at wheat harvest, and we found wherever we had this unit we found zero or no volunteer wheat in the falling season. So volunteer wheat management is another problem in our region, and this harvest weed seed control can approach or can help controlling some of the volunteer wheat issues.